Hello everyone. This presentation is dedicated to one of the most fascinating and fast developing technologies of our time, augmented reality. Let's start by understanding why we choose this topic and why it matters today. We choose AR because this technology merges the digital world with reality and is already used in our daily lives. Snapchat, Instagram filters, games, trying on furniture or makeup. This is also important for our future as information system specialists. This presentation explains what AR is, how it works, and what challenges it faces today. We will also look at its impact on business and society, real examples of AR in use, and our final conclusions. AR is an immersive technology that adds virtual 3D objects to real world around us. It combines what we see in reality with computer-generated elements, creating the illusion that digital objects exist in real space. In simple terms, AR merges the physical and the digital worlds. There are several main types of AR reality, and each of them works a bit differently. The first one is marker-based AR. It uses a visual marker like a QR code to display a 3D object, often used in games or education. Then markerless AR, which doesn't need any markers. It uses GPS and sensors like in Google Maps Live View or Pokemon Go. Projection-based AR shows digital content directly on real surfaces, for example in exhibition or industrial design. Superimposition AR replaces real elements with digital ones. Surgeons use it to overlay organs or data during operation. And finally, outlining AR helps to highlight edges and structures, for instance, in car design or architecture. An AR system is built from three main parts: hardware, software, and user interaction. Hardware includes the devices and sensors that capture and display data, like AR glasses, cameras, and processors. Software interprets this data using AI development kits such as ARKit or Vuforia, and turns it into interactive 3D content. And finally, the user interacts with AR through gestures, voice, commands, or touch, making the experience natural and intuitive. Now let's look at how all these elements actually work together to create the AR experience. Every AI system must detect the presence of one or more objects of interest, align their position, and continuously track their movements.
So what happens when your device mixes the real and digital worlds? An AR-enabled device with a camera such as smart glasses, a tablet, or a smartphone parses a video feed to identify a physical object or the environment around the user, such as a piece of machinery or the layout of a warehouse. A digital twin, a 3D digital replica of the object in the cloud, connects the real and virtual environments. It connects information from the physical object and digital. The augmented reality device then downloads information about the object from this cloud. It superimposes digital information of the object using markers or trackers like GPS, accelerometers, orientation and barometric sensors, and more. This creates a part real, part digital 3D interface. Thanks to real-time data flowing from products, the user can interact with the object or environment by moving around and sending commands to the cloud through a touchscreen, by voice, or with gestures.
The readiness level of AR really depends on the context and the industry where it is used. For example, in gaming and entertainment, AR is already commercial and quite mature. It can be rated around TRL 8 or 9. However, in healthcare and industrial application, AR is still mostly in pilot stages, around TRL 6 to 8, mainly because of high costs, strict regulation, and safety requirements. In this sector, decision makers tend to be more conservative, since errors can lead not only to financial losses, but also to safety risk. Meanwhile, consumer AI wearables such as smart glasses remain at a lower level, roughly TRL 3 to 5, because they are still in early development and faces comfort and usability challenges. So overall, AR maturity is heterogeneous. Some parts of the technology are highly advanced and stable, while others are still evolving. You can see this distribution clearly in the table on the slide.
Although AR has progressed a lot, there are still many challenges that prevent it from full-scale adoption. From the technical side, devices often struggle with battery life, heat, and limited processing power. Software integration is also difficult. AR must align digital elements with the real world accurately in all lighting conditions. From the user perspective, comfort and visual quality are also key issues. Many headsets are still very heavy, and the lack or motion blur can break the immersive experience. And finally, development remains costly, while high quality AR content is still quite limited. This slows down mass adoption. Continuing with challenges, one of the biggest technical issues lies in the optics and display systems. Ideally, AR glasses should look like normal eyewear, so comfortable. But shrinking all the components into the small form is extremely difficult. Also, another problem is visibility. Most displays are too dim outdoors and can't block real-world light, making virtual objects look transparent. And even with today's vast micro displays, achieving a wide field of view and high resolution at the same time is still technically impossible. But even if we solve these optical and technical issues, there is another side to consider, which is the human experience. And even if the optics works perfectly, there are still human factors. Fixed focus lenses can cause eye strain when users switch between near and far objects. Also, dark or glowing head-mounted displays can make social interaction uncomfortable. People may feel disconnected when talking to someone wearing AR glasses. For AR to be widely accepted, it has to look and feel natural in daily life. Let's talk about future directions. Advances in AR hardware and software is the first one. So, ongoing advances in AR hardware and software will address many of the current challenges. For example, improvements in processing power, battery life, and display technology that will enhance the performance and usability of AR devices. The second one is integration with AI and machine learning. The fusion of AR with artificial intelligence and machine learning is leading to smarter, content-aware applications. AR glasses equipped with AI can analyze real-world objects and provide relevant information instantly. The third one is the role of 5G. The role of 5G networks is crucial for AR development, providing the low latency and high bandwidth required for seamless real-time AR experiences. The next one is expansion of AR applications. Expanding the range of AR applications beyond gaming and entertainment is crucial. AR has the potential to revolutionize industries such as healthcare, education, and manufacturing. By exploring new use cases, AR can provide significant benefits and drive further adoption. And the last one is collaboration and standards. Collaboration between companies, researchers, and regulatory bodies is essential for the development of AR. Establishing industry standards and best practices will ensure compatibility, security, and ethical use of AR technologies. Cooperation will accelerate innovation and address common challenges. So, about augmented reality market growth. In current year, the AR market is worth $95 billion. And by 2030, it's expected to grow to $511 billion, reflecting a 40% approximately compound annual growth rate. So, there are some risks to physical and mental health that should be considered also. The first thing is visual sensory issues and also auditory sensory issues. Then we also have ergonomic issues, that means discomfort or fatigue from wearing AR devices for extended periods, especially if they are heavy or poorly fitted. Also, overstimulation and chronic distraction. AR can undermine sustained attention and promote distraction. AR systems overlay digital information onto the real world, including notifications, messages, instructions, labels, interactive elements, etc. Users can be flooded with visual and auditory data, making it difficult to focus on essential tasks. Also, we have here addiction. AR users can develop a pattern of compulsive and problematic use of AR that may potentially qualify as an addiction. Many studies already have shown the addictive and compulsive behaviors that users develop towards their smartphones and internet usage, given the wide variety of features that they offer. And the last one is disconnection from reality. In psychology, dissociation is a mental process in which individuals disconnect from their thoughts, feelings, experience, and surroundings, or other aspects of their life. So disconnection from reality may lead to emotional numbness, impaired cognition, or disrupted social functioning. The other group of risks is security risks. The first one is data privacy concerns. AR applications often require access to users' camera, microphone, location, and sometimes even personal information. This data can be sensitive, especially when AR applications are used in personal or professional environments. Also, we face phishing and social engineering attacks. AR technology can be manipulated to create highly convincing phishing or social engineering attacks. By overlaying digital content onto the real world, attackers can deceive users into interacting with malicious elements disguised as legitimate features. Unauthorized access to AR devices. These devices, especially those used in professional or sensitive environments, can become targets for unauthorized access. If an AR device is compromised, the attacker could gain control over the device's camera, microphone, and all other sensors, allowing them to spy on users or gather any other sensitive data. The next one is the content manipulation and the misinformation. AR technology blurs the lines between reality and the digital world, making it easier for malicious actors to spread misinformation and manipulate content in different ways. Physical safety risks. The integration of digital content with the real world can also pose physical safety risks if not managed properly. AR can be highly immersive, leading to distractions that might result in accidents, especially when users are in public or any hazardous environments. And the last one is intellectual property theft. In professional and creative industries, AR can be used to visualize proprietary designs, prototypes, or other sensitive intellectual property.
AR creates substantial value for society and the economy by transforming how people learn, access healthcare, work, and experience culture. In education, it makes learning more immersive and interactive. Students can explore complex topics through 3D models right in the classroom. In healthcare, AR assists in surgery planning, training, and rehabilitation, helping doctors work with higher precision and fewer risk. In industry and business, AR supports manufacturing, logistics, and employee training by visualizing complex processes, reducing human error, and increasing productivity. Workers can receive step-by-step digital instructions through smart glasses, while companies use AR for remote maintenance and product design collaboration. Beyond education, medicine, and industry, AR also enrich cultural experience. Museums and heritage sites now employ AR to visualize artifacts, architecture, and ancient environments, allowing visitors to interact with history in new ways. These applications demonstrate that AR is not only a technological innovation but also a powerful tool for accessibility, inclusion, efficiency, and lifelong learning. AR can work in several ways. Let's start with the most common one, through a phone camera. Then they use smartphone, the camera acts as our eyes. The device continuously scans the real environment, and the AR engine calculates distance and surfaces. The virtual object is then encouraged in space, so it stays in place as we move around. With AR glasses, there's no need to look through a hole. The digital content appears directly in your vision. Cameras and depth sensors map your surroundings, and microprojectors display virtual objects in front of you. You can look, speak, or move your hands to interact. Another way to use AR is through special devices in industry like manufacturing, automotive, and healthcare. These systems project digital data directly onto real objects, helping workers, drivers, and doctors perform tasks with generated precision. Examples is instruction in factories, navigation in cars, and surgical glasses.
So now let's take a look at the two of case studies. The first one is the Sephora virtual artist. Sephora, as a leading global cosmetics retailer, launched its virtual artist feature in stores and mobile apps. This virtual artist uses AR and AI-based facial recognition to allow customers virtually try on makeup, as you can see on the pictures. Despite this brightful idea, there was a problem that its usage remained low, as many users simply didn't know how to use it and about its existence. So the solution was that Sephora created a video tutorial showing how the AR features works, and also used marketing as push-up notifications, in-app messages, etc. So after this implementation of a campaign, we can see some meaningful results. For example, 28% in uplift in AR makeup feature user adoption, and also increment in other metrics such as increase in usage per user and also increase in overall VA traffic. The other case study is Boeing AR for aircraft assembly. So Boeing, one of the world's largest aerospace manufacturers, has integrated AR into its aircraft assembly and maintenance processes. This initiative aimed to simplify this highly complex process. So what was the problem? Aircraft assembly, particularly wiring installation, involved thousands of individual steps. Technicians relied on paper-based manuals and 2D blueprints, which was time-consuming, human errors were performed, and also difficult to update or share among different teams. These limitations led to rework, to some kind of inefficiencies, and also extended training periods. So, the solution was that Boeing introduced an air-guided assembly system developed in collaboration with Upskill Skylight and PTS Euphoria platforms. Technicians wear air glasses that project 3D wiring diagrams and step-by-step work instructions directly onto the real aircraft structure. As a result, we can see that it was a significant error reduction, productivity improvement in 20% time faster completion per task, training efficiency improvements, and also working satisfaction. So in summary, augmented reality is a technology that combines the real and digital worlds, allowing users to see virtual objects superimposed on the physical environment. Today it is used in the education industry, healthcare, and other industries. Key benefits include improving of learning and training, increasing production efficiency, and reducing errors, but also there are many others. And the key challenges include hardware and software limitations, data and security, privacy issues, health risks, and sensory overload. The future of AR, it is integration with AI and machine learning, creation of integration standards, and this technology is nowadays shaping a new dimension of interaction between humans and the digital worlds, as it helps connect people through innovation. Here you can see our references. Really appreciate your time, and we hope that you enjoyed our presentation. Thank you very much for your attention.